In math and programming, we have different number systems that serve different purposes. In our day-to-day life, we use decimal or base 10 numbers, which can contain digits 0 to 9. But computers don't understand these digits. They only understand zeros and ones. That's why we have the binary or base 2 system. So a number in this system can only contain zeros and ones. Now we can take any number and represent it as a binary. For example, the number 255 in the decimal system is equivalent to 8 ones in the binary system. It's a very long number. That's why we use the hexadecimal or base 16 numbers to shorten binary numbers. A hexadecimal number can contain the digits 0 to 9, as well as the letters A to F. As you can see, hexadecimal numbers are more compact. Now in programming, we use hexadecimal numbers to represent colors. You probably heard of RGB or red, green, blue colors. Using only 6 digits of a hexadecimal number, we can represent any color. That's very useful. We don't have to deal with really large decimal or binary numbers. Now let's see how we can represent these numbers in C++. So I'm going to declare an integer called number and set it to 255. Now if you want to represent this number in the binary system, we type 0b as a prefix, and then we type a binary number. I'm going to type 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8. Now let's print the number. Take a look. We get 255, okay? Now we can represent the same number in the hexadecimal system. So instead of 0b, we type 0x, and then we type a hexadecimal number. In this case, double F, which can be uppercase or lowercase. It doesn't really matter. Let's run our program one more time. Look, we get the same number. Beautiful. Now, most of the time, I would say 99% of the time, we use decimal numbers. But depending on the kind of application you're building, in some situations, you may want to represent a number as binary or hexadecimal, okay? Now, irrespective of how we represent numbers, our numbers can be positive or negative. If we're dealing with a positive number, we don't have to type a positive sign. It's assumed by default. But for negative numbers, obviously, we have to type a minus. Now, in C++, we have a special keyword called unsigned. If we apply this to a numerical type, that type cannot accept negative values. Now, on the surface, you might think this is a good value, but it can actually cause programming problems that are hard to spot. For example, let's print this number on the console and see what we get. So we get this really large positive number. As another example, we might initialize this number to 0, and then somewhere else in our program, we might decrement this number. Now, if we print this, instead of -1, we're going to get this really large positive number. So my suggestion is to stay away from the unsigned keyword. Just because C++ has this feature doesn't mean you should use it. That's why earlier in the course, I told you that you don't need to learn all of C++, all of its features to build useful and substantial programs. So stay away from the unsigned keyword.